In this video for section 15.1, we're going to talk about writing a linear regression equation with multiple independent or x variables. In section 14.2, we wrote linear regression equations with one independent or x variable. Now we're going to have more than one. And so we will identify each of them with a subscript, x1, x2, x3, x4, however many we have. And each independent variable will have its own slope. So we'll have b1, b2, b3, however many slopes we have, which is the same as the number of independent variables. We will have only one constant term. So we have multiple slopes, but one constant term or y-intercept, and that's b0. So this is what the equation will look like. We'll have b0 plus b1 times x1 plus b2 times x2 up to however many independent variables we have. So we can test whether our overall model is significant. Our null and alternative hypotheses for this test will look like this. Our null hypothesis is that b1 is equal to b2 is equal to b3. All of the slopes are equal to 0. Our alternative hypothesis is that at least one of the slopes is not equal to 0. So this should remind you of the null and alternative hypotheses for an ANOVA test. Our alternative hypothesis is not that they are all not equal to 0. So it's not b1 not equal to 0, b2 not equal to 0, b3 not equal to 0. One or more of them may be equal to 0, but at least one of the slopes is not equal to 0. That's the alternative hypothesis. If we fail to reject the null hypothesis for our overall model being significant, that means that our overall model is not useful for describing the situation or making predictions. And we can also test each individual slope for significance, and this will be our null and alternative hypotheses for that. Our null hypothesis is that that particular slope is equal to 0. Our alternative hypothesis is that that slope is not equal to 0. And in order to use our model to make predictions, we want all of the slopes to be significant, or in other words, we want our p-value to be such that we are rejecting the null hypothesis for each slope. If we find any that we do not reject the null hypothesis for, then we should remove those variables from our model before we use it to make predictions. So we are going to look at an example here. We have a real estate firm that wants to develop a model to determine the selling price for a house. And so these are the possible independent variables: home size, age of the house, number of bedrooms, number of bathrooms, and garage size. And you can imagine that all of these variables can affect the price of the house. So we have some data. This is, as usual, found on Blackboard for a sample of 319 residential properties. And for each house, we have the sales price, and we have each of these data values. We want to determine the regression equation and test it for significance using alpha equals 0.05, and also test each slope coefficient for significance. So here is my data. You can see that I have the price, the square footage for the house, the age, the number of bedrooms, number of bathrooms, and garage size. So what I'm going to do is I'm going to go to Stat, go to Regression, Regression again, and then Fit Regression Model. So just like we did when we had one independent variable, it's the same process. It's just that we're going to put all of our x variables in this continuous predictors box. So my responses is my y variable, so that's going to be price. And my continuous predictors, I'm going to put these in. Now, I want to put them in order. When you're doing the MyLab problems, it's going to give you the variables in order, and you want to put them in order. So instead of just clicking randomly on one of these, I'm putting them in order because that's the same order that Minitab is going to give me the variables in the equation, and so that's just going to help me keep track of which is which. If you don't put them in order, then it's going to be a little bit harder for you to keep track of which variable is which in the equation. Then I click OK, and here are my results. So here's my equation. My constant term is 31,128. And then I have my slope. This is going to be times x1. x1 would be square feet. age would be x2, so minus 1,144 times x2. Bedrooms would be x3, so minus 8,410 times x3, etc. So in the homework, you're just going to plug in these coefficients into the equation where they go. And then I'm going to test my overall model for significance. To do that, I go down to my analysis of variance table, and I look for the regression row. The top row, the F value there and the P value there are where I test my overall model for significance. So overall, I have an F value of 277.77. I would put that into MyLab if needed. And then my P value there is 0.000. So since that's less than 0.05, I'm going to reject my null hypothesis there, and that is significant. So the overall model is significant. To test the individual slopes, we go back up to the coefficients table. And in this table, I have t-values and p-values. And so you're going to enter, again, the t-values into MyLab and the p-values, and use the p-values, of course, to determine whether you reject or fail to reject the null hypothesis. So for each of the variables, so for the square feet, for example, this is testing the slope for square feet. So I have my t-value of 15.70 and a p-value there of 0.000. That's less than 0.05, and so I reject the null hypothesis for that. And so as you can see, each of these p-values, they are all less than 0.05. And so that means that I can reject the null hypothesis for each of the slopes. So all of my slopes are significant. All of these variables are something that can be used to predict the price of the house.